Alright class, this video is going to be proofs with angles and parallel lines and a transversal. So again, this should be a familiar picture. We got three lines. One's the transversal, which is line Z, because it actually intersects lines W and X at two different points. And it creates these four angles here and these four angles here. And these lines are parallel because we have two things, either the arrows or we also have the double bar symbol. Let's move on to the next slide. Oh, for those that are curious, this is the standard we're working on currently. There'll be more as we go along. There's, I think, about between 40 and 50 of them. All right, so let's prove the first one. The first one we're trying to prove is that alternate interior angles are congruent. So since what's given to us, the lines are parallel, we already know that corresponding angles are congruent. And we're trying to prove alternate interior angles are also congruent. So that can be either 4 and 5 or 3 and 6. I just chose to use 4 and 5. So when you're doing proofs, you always have to have some kind of clue. In this case, we got the clue that lines W and X are parallel. And again, I'm writing this out because I don't honestly have a keyboard, so I have to do it this way. But if you're doing it on paper by hand, you know, I would use a parallel symbol and the angle symbols instead of literally saying parallel or angle. And here, what's the reason? It's given. All right, let's move on to the next one. And again, based on our prior knowledge, we can deduce that corresponding angles are congruent. So we need a pair of corresponding angles that has some relation with 4 and with 5. So what do we got? So let's just circle those 4 and 5. So I can use, what can I use? I can use 1 and 5. I can use that. Why not? That should work. They're corresponding and they relate to 4 and 5 because 5 is actually in the pair of 1 and 5. So we'll just put here angles 1 and 5 are congruent. And how do I know they're congruent? Because they're corresponding angles. And corresponding angles are congruent only if the lines are parallel. So I'll put here corresponding. You would actually put corresponding angles, postulate, and or theorem, depending on the book. Here, for number 3, I also know, just by looking at the picture, 4 and 1 are congruent. So angles 4 and 1 or 1 and 4 are congruent. The reason I know those are congruent because of my prior knowledge, those are actually vertical angles. And if you forgot what vertical angles are, and you forgot what corresponding angles are, I would watch a different video to try to refresh my memory. Proofs are easy and doable if you remember your properties and your terms. Because this proof is easy. We're pretty much done. Now, what do I notice? I notice that 1 is the same as 4. They're both congruent. And 1 and 5 is also the same. They're both congruent. So angles 5 and 4 are congruent to the same angle, which is 1. And since they're congruent to the same angle, then guess what? They're congruent to each other. And what property is that? That is simple. That is just transitive property. The way I understand it is I'm transitioning from 1 and 4 to 5 and 4. It makes sense because if 1 is 30, 5 is 30. Since 1 is 30, 4 is 30. So that means 5 and 4 got to be congruent. And this looks like this one's done. Yep, I proved alternate interior angles 4 and 5 are congruent. I proved it with corresponding angles, vertical angles, and the transitive property. All right, let's do the next slide, which is alternate exterior. But it's very similar. So with alternate exterior, I got 1 and 8. Because it's got to be outside the two lines. Or I also got 2 and 7. I just chose 1 and 8. So again, with every proof, you got to have some kind of information, and the one we have is the same one, which lines W and X are parallel. No, I think it's spelled like that. All right, and then how do I know that? It is given. And let's move on. It's basically the same thing. We're going to use corresponding angles. So here, we're going to do 1 and 8. So same thing. Let's just circle the ones we're trying to prove, which is 1 and 8. I'm trying to prove a 1 and 8. I need some corresponding angles that relate to 1 and 8. So why not just use 4 and 8? Those are corresponding. And you notice I'm basically painting the same picture I painted with the alternate interior. So we're here. So then here, corresponding angles 4 and 8. And let me write this correctly. Angles 4 and 8 are congruent. And how do I know that? Simple, because since the lines are parallel, because I was given, that was our clue, corresponding angles are congruent. There we go. And moving along, number 3, I already can see 1 and 4 is congruent. So angles 1 and 4 are congruent. And why they're congruent? Because they're vertical angles. They're basically opposites of each other. One's facing this way, one's facing that way. Remember, wherever there's an X, there's bound to be vertical angles. And we know vertical angles are always congruent, no matter what. Because this is just a separate situation. Here, the corresponding angles, which is 4 and 8, the lines got to be parallel because one's further away from the other one. So in reality, there is no connection there. So if these lines aren't parallel, these actual angles could be not equal. So just to give you an example, I'll just show it real quick. We'll just do something. This proof is pretty much done. I'm hoping you can see what step 4 is. So here I'll just do something quick. This is one line, this is another one. Notice these lines aren't parallel. So if I do whatever this angle is right here, let's say this is 1. Let's call this, I guess, 5, 2. Hold on. Not easy with the mouse. Alright, that's 5. Now you notice 5 and 1 don't look the same. And they don't. They're different. So what happens if I do this? Let's see if I can... Yeah, what if I move it even more? Notice, look at 5 and 1. They're definitely not the same. 5 is a little bit more bigger than 1. And so since these lines aren't parallel, that's why these corresponding angles are congruent. So the only way corresponding angles are congruent if the lines are parallel, if they're equally spaced. That's how I see it. Alright, so this is an example of 2 corresponding angles, which are these 1 and 5 aren't congruent because these particular lines, or really segments, are not parallel. Alright, so let's just finish this proof. We got 4. Alright, so I can really see, since 4 is equal to, the measures of 4 and 1 are congruent, and the measures of 4 and 8 are congruent. Both 8 and 1 are congruent to 4. So then that means angles 1 and 8 are congruent to each other. And what property is that? The same property I talk about all the time, which is transitive property. There we go. And sorry for the, I guess, not neatness, but you get the gist of it. Alright, let's move on to the next one. So we did alternate interior and exterior. Now let's move on to same side interior and same side exterior. Same process, just a little bit more, but it's about the same thing. Same picture. Now we're dealing with same side interior. Same side interior are angles that are on the same side and inside lines W and X. So we got 3 and 5 or 4 and 6. Let's just work with 3 and 5. So for 3 and 5, let's just put what's given. What's given is lines W and X are parallel. And of course we know that because it's given. Alright, moving on. Now since I'm trying to prove 3 and 5 are, let's just circle those. We're trying to prove those are supplementary. Alright, let me just get a pair of corresponding angles real quick, because I know I can use that. So let's just pick, I guess 1 and 5 is fine. Let's just change the color. So let's go with 1 and 5. I know those are corresponding. All right, so let's go with that. And we know since the lines are parallel, corresponding angles are congruent, so that means angles 1 and 5 are congruent. Okay, and then what's the reason for that? The reason for that is they are corresponding angles. Alright, since angles 1 and 5 are congruent, then that means their measures are the same. So again, I would write measure of angle 1 and measure of angle 2. So, well, let's try it. Why not? So measure, and then here I would put this. And I'm just going to write it out because I don't want to be here for too long. Alright, so we just put here the measures, and of course let's put this all over here. There we go. The measures of angles 1 and 5 are equal. Again, I'm just writing this out in words, but you should know what the symbol is. The symbol will be little m, angle 1 with the equal symbol, little m, angle 5, and that's it. That would be the ideal way to do it, but since I'm typing, I have to actually just write it out. And here, how do we know that the measures are equal? Simple, because of the definition of congruent. Now again, this is just by definition. Since the angles are congruent, then their measures got to be equal. So that's the reason I know that, because they're by the definition of congruent. All right. So let's move on with that. And for 4, now we need to, since we're trying to find supplementary, we need to use our prior knowledge to find angles that, just by looking at the picture, add up to 180 and have some kind of relations with 3 and 5. So since I used 1 and 5, let's look at 1 and 3. I did this in class, but for some of you that didn't go to class, this is what we did. We use 1 and 3. Why? Because they make half a circle, which is 180 degrees, or a straight angle. And since those angles are adjacent and make an actual straight angle, or technically a line, we call that linear pair. So here, come on. There we go. All right. So here we can say that angles 1 and 3 are linear pair. And what is the reason for that? How do I know linear pair? Because I know the definition of linear pair. The definition tells me that angles 1 and 3 are linear pair because they're adjacent and they make a straight angle. Same thing that the definition of congruent tells me the measures of 1 and 5 are equal. And technically, the definition of corresponding angles, or corresponding angles themselves, are congruent because the lines are parallel. So all these reasons relate to each one of these statements. Now, since I know that 1 and 5 are linear pair, I also know by definition that angles 1 and 3, angles 1 and 3 are linear pair. I know also by the definition of linear pair that angles 1 and 3 are also supplementary. See if it fits. It does. Okay. And then again, same definition. Same definition. And then here, all right, we're pretty much almost done. Now again, this is all just logical sequence. Since I know angles 1 and 3 are supplementary because they were linear pair, then by the definition of supplementary, here I would put the measure of angle 1. So I'm going to have to write this out, even though honestly I wish I can just write it out. The measure So I just put here measure of angle 1. I'll write it out in words. I'm hoping you guys can remember what this means. So measures of angles 1 and 3 have a sum. No. Let me just do it like this. I'll just put M1 plus M3 is equal to 180. And then I'm going to cheat a little bit. Let me take the pen. Hopefully this looks okay. Oh, it will. Hold on. I know what to do. Let me have a little space here. Yeah, there we go. And then there, let's just put the little angle symbol. That's supposed to be the angle symbol. I know it looks ugly, but it's what I got. Let's try it again. Or no, that's I can't live with that. Hold on. Let's do this real quick. Let me take this. Yeah, let's put it here. That looks better. Okay. And do another one. That looks better. Okay, good. So now that's a little better. It's not perfect, but that'll work. All right. So that's basically saying the measure of angle 1 and 3 add up to 180. And the reason we know that is by definition of supplementary angles. There we go. And here also too is linear pair angles, definition of congruent angles. Okay, so just letting you guys know. I'm just being a little lazy with it, but technically it's angles. Why is it angles? Because we're working with angles. Just, just pointing out the obvious. All right, so moving on. All right, now let's just continue with this. So we don't technically need this all the way. Hold on, let me put this. All right, so let me just do this. Yeah, we don't need this because we need more space. All right, so boom. Let's move this up here. There we go. All right, move this here. That's fine. All right, so let's finish with this. All right, so then let's put the two together. Let's do this. Instead of putting angle 1, I can actually put angle 5. So I can put here measure space 5 plus measure space 3 is equal to 180. Right? And how can I do that? Why can I replace 1 with 5? Because they're congruent. And then what's the property of replacing one thing with another? We call that substitution. Substitution property. There we go. All right, now that I got that, I'm done with that. Oh, let me make sure I put the let me make sure I put this little angle symbol, and then another one right here. There we go. Oh, it's not so bad. Okay, I thought it'd be worse. All right, and then next thing we got left is the last step. I'm pretty much done. Here, 8. Then we know if angle 5 and 3 add up to 180, that means the angles 5 and 3 are supplementary. Because how do we know they're supplementary? Real simple. Because what tells me that? The definition, by definition. And again, I'm being lazy. It should say supplementary angles, except for this one, it's number 7, but everything else has supplementary angles. So just to recap, I used corresponding angles. And since I used that, I knew they were congruent. Since they were congruent, the measures had to be the same, just by definition congruent. Then I used the linear pair, which is the green here. They make a straight angle, so by definition, I knew they were linear pair. And since they were linear pair, by definition again, they are also supplementary. And since they're supplementary by definition of supplementary angles, they add up to 180. And since I already knew angle 1 and 5 had the same measures, I can replace angle 1 with angle 5. And that's by substitution property. And since the measures of angle 3 and 5 are equal to 180, then that means those angles are, by definition of supplementary angles, supplementary.